Hello, my name is Brandon Southworth. Today we're going to talk about other common functions you might run into. Uh, One thing to note: all these common functions are centered around x equals 0 or the origin. So, and the whole point of the common functions will be to, if I see this particular form of function, I know where it's going to fall. So the first common form is ax to the n power. Here, n is assumed to be positive. So, and for most all these, we're going to break it down into: is your exponent odd or is your exponent even? So exponent is odd would be first. So then we're going to assume that a is 1 for now. If we look at f of x equals x, in that case the exponent is 1. This picture here is just a straight line. So the thing about the straight line, what I make note of is when x is positive over here, y is also positive. When x is negative, y is also going to be negative. As you keep going, we look at f of x equals x cubed. I'm going to draw this out. I'm not going to go through the points or make it tables. So you can make tables. This one looks like this. If you do f of x equals x to the 5th, the picture looks something like this. And the biggest difference between x cubed and x to the 5th will be near the origin, it'll be flatter. So we're going to come up very, very fast, hit this, and we're going to flatten out a little bit more and go up. In fact, as it is odd, as it gets bigger, the area right here will be near the origin will be a little bit flatter, basically between +1 and -1. All right. Now, if we look at what happens if the exponent is even, f of x equals x squared. That's our first even one. Well, x squared is always going to give you a parabola. Whoa. So here we are. And we'll come down to the origin, just curve around here. If f of x equals x to the 4th, you're basically going to have this same shape where the two ends go up. So here we are. And again, just like before where we had x cubed, x to the 5th, x to the 7th, between -1 and +1, your curve kind of flattened out. Same thing. So we're going to come down. As we get close to 0, it's going to be a little bit flatter. If I go to x to the 6th, it's going to be a little bit flatter. So for us to keep in mind is, if you have an odd exponent, you're going to go something negative and something positive. If you have even exponent, you're going to have something that's parabolic-like, that means it's going up. the center here in both cases, as the exponents gets larger, it's going to get flatter in there. So we might look at graphing something like I don't know, f of x equals 2 minus x cubed over 5. And just to be clear, if you're not sure that this matches this ax, the in form, we'll just look. This is actually minus 1 times x cubed over 5. I can write this as minus 1/5 times x cubed. Now, because it's x cubed, it's odd, so I expect it to go like this. Now, one thing I'll point out, and we'll test this in a second, but this one here has a negative. What's that going to do? Well, it's going to take your positive y values and make them negatives, make your negative values, make them positive. So essentially, we're going to do the opposite of what we have. And all these pictures up here, we always had a positive 1 coefficient. If I put a negative, it means that we're taking these things and we're going to flip them over. So because of this negative, I expect my picture to look more like this. And we'll test that real quick. So we know we're going to be centered around 0. So just choose, make a table here real quick, and just choose a couple points on either side of 0. One on the left side, one on the right side of 0. So I don't know, minus 1 and say 2. You don't want to choose too big because x to the cube or x to the 5th as it gets larger will grow very, very fast. So here we have minus 1/5 cubed. This is going to be minus 1/5 is minus 1, or just plus 1/5. Minus 1/5 times 2 cubed. Look at that. That's going to be minus 1/5 times 8, or 8 over 5. If you want to, you pop out your calculator and you'll find that 1/5 is 0.2 and 8 over 5 is 1.6. That's going to help. If that helps you graph the picture, go ahead and do it. So here we are. 1, 2, 3, 4. 1, 2, 3, 4. 4. With a point minus 1, 1/5. So minus 1, we're just barely up here, so like right there. At 2, we're at 1.6. So I'm sorry, we made a mistake. At 2, I said this is a minus 8 here, so this is a minus 8 right there. This is a minus 1.6. So at 2, we're down here at minus 1.6, so somewhere in there. So you can see over here, we have to be coming down like this. Over here, we're going down. So we're going very, very fast. And we're kind of flatten out here through 0. And curve down again very, very fast. So that's a little bit better. Again, I'm not grading people as artists, but that's what you should kind of look for. All right, next we'll be looking at the form a over x to the n. Now here's the thing on this. You divide by x. If you divide by x, the denominator can't be 0, so x cannot equal 0, which means my domain is minus infinity to plus infinity except for 0, or it's this. And again, that means we'll never touch the y-axis. We'll get close to it, we won't touch it. Again, we'll look at what happens when n is even or n is odd. So, we have an odd exponent. You have something like, well, f of x equals, say, 1 over x to the 1. I can't cross it. The way it's going to behave is we're going to come down like this. Over here, we're going to come like this. Now, if you're drawing it correctly, this top curve and the bottom curve follows over a line like this. This should follow up on each other exactly. Now, as this exponent increases, oh man, as this exponent here increases, what's going to happen is the rate at which we climb here, or the rate at which these go to positive infinity here, negative infinity here, or here and here, will be faster. So there won't be a slow descent here. It'd be more like we'll come down faster through there. So I'll attempt to draw it. So f of x equals 1 over x squared. Nope, not x squared. X squared is not odd, so we can't do that one. We're going to come down. So we're going to go up faster, and we're going to scooch down here faster. Yep. In general, you kind of anchor on the 1 point right here, the minus one point. So that will change as your thing to, but kind of think about it that way. This kind of be a fixed point, more or less, and then how you approach it will be faster or slower based on your x cubed or x to the 5th. Now, if you have an even exponent, so for example, f of x equals 1 over x squared. The thing to know about here is x squared or x to the 4th or x to the 5th will always be positive. It doesn't matter what x is. When you square it, raised to the 4th, it's always positive. So there won't be a negative on the odd one up here, right? Up here, one of these was a positive curve, one of these was a negative curve. Because x squared is always positive, both these curves are going to be positive. And essentially the curves are exactly the same as above, which is negative, just that they're both above the x-axis. We do x to the 4th, same thing. The speed at which we come down, at which we grow up or go down, it goes very fast, so it'll be you know how this kind of seems a little bit faster over here to collapse or grow? Same thing. So, quick summary. For a over x to the n, n is odd, you have one below and one above. N is even, both will be above. Okay, so let's give an example. Graph f of x. Let's do I don't know, 1 over, we'll do 1. 3 over x cubed. And really, as before, since we're 0 and 0, I should be able to look at the fact that this is odd and know immediately, oops, the negative side is going to go down, the positive side is going to go up. And then we just need to verify that we're correct. So we might say x equals, I don't know, -1, say +2. So -1 cubed will be -1, so I get -3. X is 2. 3 over 2 cubed, 3/8, which is 0.37-ish, if you calculate it out. So here's my picture. Now note, the -1 gives you -1, which is what we expect to be down below. The +1 gives you +1, which we expect to be right up here. So -1 we are at -3, so right here. And at 2 plus 2, we're at 3/8. So it's just over a quarter, but less than half. So half is right here, so maybe here. I know I should come down. Over here, we're going to come down very, very quickly. Over here, start close to the x-axis, come down here, hit that point, and then just shoot down very quickly. All right. Finally, we have two more. We have 2 more to go. Next common function, or next common form, is ax 1 over n. And remember, if you have a rational exponent, that means you actually have radicals. So we're looking at a times the nth root of x. And let's talk domains. If you recall, over here, the square root of -4 equals 2i. 2i is not a real number. So, and the index here is 2. So we're only graphing real valued functions. So all the values of x that make the inside negative, we're going to throw away, which means domain. If n is even, so anytime n is even, the inside can't be negative, so the domain will be 0 to infinity. But if you look at the same version, if I do the cube root of -8, 1 number multiplied by itself 3 times would give me -8. Well, would -2 work? Is -2 times -2 is that -8? Well, 3 negatives make a negative, so and 2 times 2 times 2 is 8, so it's true. So if n is odd, our domain is going to be -infinity to infinity. So what that means is n is even is telling us we're only going to have half a graph, half from the x-axis to the y-axis, one direction only. The n is odd is telling me we're going to go from both directions. So as before, we're going to look at how does n behave. So n is odd. Well, the first one, if I have f of x equals x to the 1/1, that's just going to give me a line. So here we go. That's it. If I have f of x equals x cubed, essentially what we're going to do is we're going to look at, well, it'll essentially be, just go up to the very, very top here. It's going to be these pictures right here, but they're going to be on their side. So the picture looks something like this. And then same picture, because, oh, I'm sorry. This should be 1/x cubed. This should be x to the 1/5. So therefore, as the n, in this case 5 is larger, we're going to be flatter here at the origin. So we're going to come in this, flatten out a little bit more, something like that. Now, when n is even, we won't have this left-hand side of each of these curves. We'll just have the right-hand side. And beyond that, they look basically the same. N is even, which means, again, the domain is 0 to infinity. So f of x equals x to the 1/2, or the square root of x if you like. Picture-wise, that's just going to be something that looks like this. F of x equals x to the 1/4, or the 4th root of x. Same thing. Again, as the power increases, the index increases, you get flatter close to 0, so it's going to come up a little more steep and then go out. So for ax to the 1/n, if n is odd, is under domain minus infinity to infinity, and your picture will be something like this. If n is even, domain is 0 to infinity. And it'll just be 1/2 of that, of this curve up here. I'm sure I draw this curve again. Something of that nature. Again, when you test it, right, you just need a point on either side of the origin. If this case, if it is even, you just need to test 1 point on the 1 or 2 points on the right side. Okay. The last one. If you have a absolute value of x, or just absolute value. Now note, in this particular problem, exponent on x is 1, which means if the absolute value was there, it'd be just a straight line. It'd be just going straight like this, or like this. But the absolute value makes everything positive. So if I had a straight line like this, all these y values here, over here, y is greater than 0. Over here, y is less than 0. Or specifically, the absolute value would leave these y values over here positive, and these y values over here would turn positive, so you end up with a v. So if I have f of x equals absolute value, it's literally just going to give me a v. Now, if I have coefficient, if you actually have an a value, you're going to need to adjust for that. The a value will either make it grow the v thinner or wider. So, for example, graph f of x equals, I don't know, 3 absolute value of x. I know it's a v at the origin. So I can test a couple points. I don't know. Make a quick table here. Let's try -2 and 4. So 3 times the absolute value of -2 is just 3 times 2 or 6. 3 times the absolute value of 4 just going to be 12. So we're going to have a very, very steep curve here. So 1, 2, 3, 4. 1, 2, 3, 4. So -2, we're up here at 6. Over here, we're going to go 4 to 12, so we're going to be way up here. And if x is 0, right, that's always going to put 0 right there. So it's going to be a V shape. It goes up very, very fast. All right. that's everything. Let me know if there are any questions. Have a good day.